Good evening, children.
Good evening, ma'am.
Good evening, ma'am.
Good evening, children. Good evening.
Good evening, ma'am.
Good evening, children. Very good evening.
Good evening, ma'am.
Good evening, ma'am.
Good evening, children. Good evening. I've shared my screen. Is it visible?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yeah, children. All right. So in this figure, all the arcs you see are semicircles. All the arcs you see, you can see an arc here, right? AED. This arc AED is a semicircle. This arc ABC is a semicircle. Here, this arc FGH is a semicircle. HID is a semicircle. FJC is a semicircle. All these arcs which you see here are semicircles. You need to find the area of the shaded region. You need to find the area of the shaded region and the perimeter of the shaded region. So we'll first carefully, understand the radius of the value of the radius of each semicircle. So you can see it here. AD is 7 meters. AD, the diameter of this semicircle, 7 meters, not centimeters, 7 meters. AC, from here to here, AC, because there is one semicircle AED on the whose diameter is AD. AD is 7 meters. There is a semicircle ABC whose diameter is AC. And how much is AC? 10.5. 10.5 is nothing but 105 by 10, which can be written as 21 by 2. So fractions are more comfortable while calculating. So we'll use 21 by 2. We are writing out the diameter. We are writing out the diameter for every semicircle, the length of the diameter. AD is 7 meter. AC. Why should you write AC? Because there is a semicircle ABC whose diameter is AC. So AC is 21 by 2. What about HD? HD. HD is the diameter of the semicircle HID. HD is the diameter of the semicircle HID. So how much is HD? HD is 7 plus 7 plus 3.5, 17.5, which is 175 by 10 or 35 by.
Ma'am,
Yes.
ma'am, our voice is heard twice, ma'am.
Is it so?
Not for me, ma'am.
Not for me also.
All right. So HD, there is a semicircle. There is a semicircle whose diameter is HD, and HD is 7 plus 7 plus 3.5. 7 plus 7 is 14 plus 3.5, 17.5, or 175 by 10, 35 by 2. Simplify. 5 tables of 5. 5 2s are 535 times. 35 by 2. There is a semicircle FJC. FJC whose diameter is 7 meters. CF is 7 meters. And then this semicircle FGH whose diameter is FH. FH is the diameter, which is 7 meters. So what you see here is we have mentioned the diameters of the different semicircles and we've written out their values. We have mentioned the diameters. We have mentioned the diameters of the different semicircles we see here. How many semicircles? 1, 2, 3, 4, 5 semicircles. We have 5 semicircles. So you can see 1, 2, 3, 4, 5 diameters mentioned here. All right. Now the area of the shaded region. Area of the shaded region is, to find the area of this region 1, I've marked it 1. I've marked this one 1. The area of this shaded region will be the area of this region. Okay, first I've written the area of the entire shaded region. The area of the shaded region is area of the region 1 plus area of region 2 plus area of region 3. That's what you see here. That's what you see here. Area of the shaded region in total, the area of the shaded region in total is area of this region marked 1. I've marked it 1 here. Area of this region 1 plus the area of this region 2. I've marked 2 here plus the area of this region 3. That's what I've mentioned here. Now let's find area of region 1. Let's find area of region 1 or the shaded portion 1. How do you find the area of this portion 1? It's the area of this semicircle minus the area of this semicircle. Area of this semicircle minus the area of this semicircle. That's what you see here. Semicircle, be very careful. The area of a semicircle is half pi r square. Half pi, see, we have to find the area of this semicircle, the semicircle which has AC as diameter. Area of the semicircle will be half pi r square. See here, half pi r square. What is r? Diameter is AC. What's the radius? AC by 2 square. That's what I've written here. Instead of using R1, R2, R3, R4 and so on, I've just mentioned the diameters and divided by 2 to show the radius. See here, I'll tell you again. We are writing out the area of this semicircle. Area of the semicircle is half pi r. What is r? Diameter by 2. AC by 2. This is r square.
Ma'am, instead of AC by 2, we can write 3.5 square.
Yeah, that's what it is.
No, we can directly write the value.
You can. I'm just mentioning the radius here. That's all.
Okay.
Minus area of this semicircle. Area of the semicircle is semicircle. Not to forget the half. Half pi r square. What's the diameter? AD. Then what will be the radius? AD by 2. So this is the radius. AD by 2 square. Half pi, radius is the diameter by 2. The value of the radius is diameter by 2 square. Don't forget the half, children. Half pi r square is the area of a semicircle. Now this is pi by 2 and substitute the values 21 by 4 the whole square minus pi by 2 into 7 by 2 the whole square. So 441 by 16, 49 by 4, pi by 2 is common. Write this in a bracket. Pi by 2 is common, and on simplifying, don't use a value of pi. Don't use 20. Let's do that finally. Don't use 22 by 7 here. So 441 minus 196 is 245 by 16. Pi by 2 here. 2 into 16 is 32. This 245 as it is, pi as it is, meter square. Do the same and finish the area, children. In the same way, you'll have to present the area for the others. Area of region 2, same fashion. Area of this semicircle minus the area of this semicircle will be the area of region 2. And area of region 3 is the area of the semicircle. Is the area of this semicircle. You can see it here. So the area of the shaded region will be the sum of these 3 areas. I want all of you to work it now. Complete area. You'll need 10 minutes for this. Don't blindly copy. Do not blindly copy from the screen. Take help from the screen. Do it on your own. Calculation, everything, do it on your own. You start working. I'll wait for 10 minutes. Please understand what you're doing. Get your doubts clarified. Kindly do not copy it from the screen. That's of no use. Use fractions, they are more convenient. Yes, I hope it's over. Somebody tell me, how do you find the perimeter of the shaded region? How do we find the perimeter of the shaded region? I want the answer like this. Tell me like this, complete this. So it's the length of the semicircle AED. Go on like that. Length of the semicircle or the perimeter. Perimeter of the semicircle. Perimeter of the semicircle AED, or you can say perimeter of the arc. This arc is a semicircle. This arc is a semicircle. AED is a semicircle. You can also say arc AED. So use the word arc or semicircle, and what will be the expression to find the perimeter of the shaded region? Yes, somebody try. If you walk along the boundary of the shaded region, if you walk along the boundary of the shaded region, how will you walk? Now I start from here, A. I walk along AED. Then
DIH.
Then I should walk along DIH. Then
HGF.
HGF. I walk along HGF. Then
FJC.
should I walk on CF? Should I walk on CF?
No,
ma'am.
No, I should deviate from the boundary of the shaded region. So then, like after coming here, I should walk along FJC. Then CBA. And I come back to start. So I have no job on AD. I have no job on AD or DC or CF or FH. I'm not going to walk on HF or CF or CD or AD. No work there. We have to walk on the boundary of the shaded region. This is the shaded region. This is the shaded region. Boundary of the shaded region. So a length of the arc AED. So you walk like this. Supposing you start from here. Supposing you start from A, you go like this along AED, then like this. You should go along the boundary of the shaded region. So like this, DIH, then like this, HGF, and then like this you move, FJC and CBA. You come back to the starting point. So the length of arc, all these arcs, the sum of the lengths of all these arcs or all these semicircles will be the perimeter of the shaded region. So it's the perimeter of the semicircle AED plus the perimeter of the semicircle DIH plus the perimeter of the semicircle HGF plus the perimeter of the semicircle FJC plus the perimeter of the semicircle CBA. Perimeter of a circle is 2 pi r. Semicircle pi r. Pi r.
Ma'am, 5 into pi r by 2, ma'am.
See here? Yeah, so that's what I've written here. Perimeter of the shaded region is what we just discussed. Length of the semicircle with AD, with diameter AD. Length of semicircle. This is length of semicircle. Length of semicircle with diameter AD. You can also mention like this. Semicircle with diameter AD. Length of the semicircle with diameter HD. This is also, you can, it's the same thing. So pi r, everywhere it is pi r plus pi r plus pi r plus pi r plus pi r. We have 5 semicircles. We need to add all their perimeters. So don't take the value of pi. Don't take the value of pi anywhere. So like this, after substituting the radius, take out pi common. We have so many fractions in the bracket. Take up the LCM. And once for all here, use the value of pi, 22 by 7. Once here, use the value of pi, 22 by 7. This is 98 by 4, simplifies to 77 meters. So the perimeter of the shaded region is 77 meters. I want all of you to complete now.
Ma'am, I did the working in splitting method, like area of arc, separating arcs.
Okay, you found this arc separately. You found this separately, is it?
Yes, ma'am. I'll
Yeah,
share
yeah.
the working.
Yeah, good. That'll be better. Yeah. Yes, Arnav, you found the perimeter of the semicircle separately and then you've added. Fine. Is it over?
For area, can't we leave as fraction?
Why? Because it's difficult to divide. Huh? It's time consuming.
Yes, ma'am.
Okay, when you work in the exam, you leave it as a fraction. Then if you have time, you come back and find the decimal value.
Okay, ma'am.
Yeah. You don't spend time in finding the decimal value first. You leave it as a fraction, and then if you have time, you can come back and find the decimal value.
Okay, ma'am.
All right, let's see the next one. I want you all to complete, because don't take this, don't, like again have something pending to be completed. Please complete it now. That's why I'm waiting. Give me your names. How many of you finished?
Arnav.
Good.
Srinivasan.
Good. Next.
Harshita, ma'am.
Finish, Harshita.
Ravya.
Harshita
Ma'am,
finished.
Ravya.
Ravya finished.
Parkavi, ma'am.
Parkavi finished. Next.
Yes, ma'am. Finished, ma'am.
Reshmika.
Shivani, ma'am.
Shivani. Now I'll ask one of you to take a picture and send on WhatsApp. Next, who's finished?
Priya, ma'am.
Okay, Priya. Sudarshan. So how do we find the area, children? Let's just see it again. How do we find the area? Now we've understood the diameters everywhere. So diameter by 2 will give us a radius. We know the diameter of every semicircle. For every semicircle, now for example, this semicircle, we know the diameter is AD. Now for this semicircle, we know the diameter is AC. So we know the diameters. We know the diameter of every semicircle here. So half of that value will be the radius. Okay, so there's no issue, or there is nothing about the radius. We have all directly. We have the diameter. So by 2 we have radius. All right. So now to find the area of the shaded region, it is the area of region 1 plus the area of this region 2 plus the area of this region 3. Area of this region 3 is direct. It's semicircle. So don't forget to use half pi r square, where r is 7 by 2. How do you find the area of this region 2? It's the area of this semicircle minus the area of this semicircle. Here the radius is 7 by 2. And for this one, the radius is, the diameter is 35 by 2. The diameter is 35 by 2. So the radius will be 35 by 4. 35 by 4. Because half of that, right? So area of the bigger semicircle minus the area of the smaller semicircle will give us the area of the shaded region. Do the same thing here. You will get the area of the shaded region. So area of region 1 plus 2 plus 3 will give you the total area of the shaded region. Next, for perimeter, what we understood is we'll have to walk along the boundary. We'll have to go along the boundary of the shaded region. We shouldn't get into the figure. Walk along the boundary. Walk along the boundary of the shaded region like this. Start at a point, walk and come back to the starting point. The length of all the path you trace is the perimeter of the shaded region. So we have 5 semicircles. One, we are walking along the semicircles. 1, then we go along the semicircle 2, then we go along the semicircle 3, then we go along the semicircle 4, and then finally we finish walking along semicircle 5. So find the perimeters of all these 5 semicircles and to get the perimeter of the shaded region. And we understood yesterday. This one we completed yesterday, children. I shared only the answer. Here you can see the steps. Yesterday I only shared the answer. 66 meters and 115.5 centimeters square. So this is the working. I'll share the material with you later. Now 3 you can help yourself, similar to the first one. Similar to the first one. So you can help yourself with this one. You need to find the perimeter of the shaded region. Perimeter of the shaded region. So what will be the length of arc PAQ? Length of arc PAQ? What will be the, see, I don't want the final numerical value. How will you find the length of the arc PAQ? They're all semicircles, children. I didn't tell you. Okay. All these are semicircles. PAQ is a semicircle. This one is a semicircle. All semicircles. All the arcs you see are semicircles. Yeah. So how do you find the length of PAQ?
Pi is 7 by 2.
Pi into 2 pi r by 2. Circle is 2 pi r. Semicircle is pi r. What is r?
7 by 2.
7 by 2. So pi into 7 by 2. Pi r. Pi into 7 by 2. Because there's a diameter. 7 centimeters is the diameter. Radius is 7 by 2. Pi r. Pi into 7 by 2 will give the length of the arc PAQ. What about the length of this arc? This arc?
Pi 3 by 2.
Pi into 3 by 2 because circle is 2 pi r. circle 2 pi r, semicircle pi r, and r is 3 by 2. So pi into 3 by 2. Pi into 3 by 2. And this one, what's the diameter?
Pi 10 by 2.
Pi into 10,
10 by 2.
Yeah, 7 plus 3, 10 is the diameter. See, this is a semicircle. For this semicircle, 10 is the diameter. So radius is 5. Pi into 5. That's all. We just have to add these three. We'll have to, okay, I'm not shown the working. That's all it is. Like, you can only see the final answer here. Where is it? Okay, I've forgotten to write the answer. Okay. Oh, it's here, children. Like wondering. Okay, it's here. It's here. The final answer is here, children. 31.4 centimeters. So the procedure or the steps, just as we discussed now, pi into 7 by 2 plus pi into 3 by 2 plus pi into 10 by 2 or pi into 5. Pi is 3.14. Pi is 3.14 and the perimeter is 31.4 centimeters. So here, 3 horses are tethered with 7-meter long ropes at the 3 corners of a triangular field, having sides 20 meters, 34 meters, and 42 meters. So this is a triangular field. This is a triangular field. 3 horses are tethered, are tied with a 7-meter long rope. See here, you can see the rope, meaning this line segment represents the rope, which is 7 meters long. And here also, the 3 corners A, B, and C. Rope 7 meters long, rope 7 meters long, rope 7 meters long. 3 horses are tethered with 7 meters long ropes, 7-meter long ropes at the 3 corners of a triangular field, having sides 20 meters, 34 meters, and 42 meters. All right. Find the area of the field graced by the horses. You should find the area of the field graced by the horses. What is the area of the field graced by the horses? And also the area of the, and also you should find the area left ungrazed. So this is the boundary of the field, children. This is the boundary. The horses, the 3 horses cannot go beyond the boundary. So this is the maximum area that can be grazed. With keeping the rope tight, the horse can, the horse which is tied at this corner A can graze a maximum of this area, the area of the sector. Maximum, it cannot go beyond that. Keeping its rope completely stretched, the horse can graze up to this area. It cannot reach this portion. It's not left loose. Similarly, this horse, the area of the field that can be grazed by the horse which is tied at B is the area of the sector. Similarly, area of this sector is the area that can be grazed by the horse that is tied at C. Now we don't know the sector angle. We do not know angle A, we do not know angle B, we do not know angle C. The question is to find the total area. We cannot find the area grazed by the horses individually. How much area is grazed by the horse here? How much area is grazed by the horse here? How much area is grazed by the horse here? We cannot find separately because we do not know the sector angles. We do not know angle A, we do not know angle B, we do not know angle C. So separately we cannot find the areas, but we can find the total area that is grazed by all the 3 horses. Separately, this horse, what area it grazes can't be found because we don't know the sector angle. Here also, we don't know the sector angle. We don't know the sector angle. So we cannot find the area grazed by each horse separately. The total area grazed by all the 3 horses we can find. So that's equal to the sum of the areas of the three sectors. Area of the field grazed is equal to the sum of the areas of the three sectors. So how do you find the area of the three sectors? So for this sector, area is angle A by 360 into pi r square. For this sector, angle B by 360 into pi r square. This sector, angle C by 360 into pi r square. What's common? R is 7 everywhere. R is 7 everywhere. R is 7 everywhere. So that's why we have not said R1, R2 and R3 because it's the same radius everywhere. So you can use R. You can use R everywhere because the radius is the same. So now pi r square by 360 is common. See here, pi r square by 360, pi r square by 360, pi r square by 360. Pi r square by 360 is common. So then you have angle A plus angle B plus angle C in the bracket. Angle A plus angle B plus angle C. Pi r square by 360 is common. Angle A plus angle B plus angle C in the bracket. Now we do not know the angles separately, but their sum is 180. Sum of all the three angles in a triangle is 180. So A plus B plus C is 180. So now 180 ones are 182s are. So pi r square by 2. So 22 by 7 into 22 by 7 into r square, 7 into 7 by 2, 77 meters square. So the area that is grazed, area of the field grazed by the three horses is 77 meters square. Now to find the area ungrazed, we need to find the area of the triangle. From the area of the triangle, if you take away the area grazed, you will get the area ungrazed. Area ungrazed is this region in the middle, this one. This is the area ungrazed. Find out, children. Once you find the area of the triangle, no, start working, take the figure. I'll not share, see, yeah, I will not be sharing this material at all because the first one I gave you time to work. The second one, I think I'll share only this answer, the second answer. The second and the third figure I'll share with you. The second one, the second answer and the third figure alone I'll share with you. First one, I gave you time to work. Now this one, please take down the figure, write this question and complete the answer now in the class. I'm not sharing the material. Complete it now in the class. Complete the full answer. Find the area of the triangle using Heron's formula. Area of the triangle minus the area grazed will be the area ungrazed. Please work. I'll just come back. Yes, what's the area of the triangle?
meters square.
How much?
336.
336. 336 meters square. All right. What's a semi-perimeter?
48.
48.
48. All right. So you can write 48 as 6 8s. So you will get 2 6 under the square root. See, you can write 28 as 14 into 2. You can write 28 as 14 into 2. So you will have 114 from this, and there's already 114. So from the two 14s, 114 will come out. You can write this 48 as 6 8s. So you get a 6 from this. There's a 6 here. So 1 6 comes out. Now 6 8s. So there's a 8 here, and from this we have a 2. 14 2s are 8 and 2 we have. 8 and 2 is 16. Square root of 16 is 4. So like that you can bring 114, 1 6 outside, and then we have root 16, which is 4. The product is 336 meters square. Heron's formula last year. So the area ungrazed is equal to 336 minus 77, which is 259. Please complete the answer. All right. Isn't this similar to the earlier one?
Yes, ma'am.
With the vertices ABC of triangle ABC as centers, arcs are drawn with radii 5 centimeters each. With the vertices A, B, and C. So with A as the vertex, with the vertex A as center, with vertex B as center, with vertex C as center. With these three vertices as centers, arcs of radii 5 centimeter are drawn. So this arc, and this arc. The radius everywhere is 5 centimeters. Find the area of the shaded region. Find the area of the shaded region. So similar to the earlier one, take down the question. Take down the figure and the information given. So similar to the earlier one, you need to find the area of the three sectors, the total area of the three sectors. Find the area of the triangle. Area of the triangle minus the area of the three sectors will give you the area of the shaded region. Here, area of the triangle is 336. You can check if it's a right triangle by using the converse of Pythagoras theorem. Or if you don't want to do all that, you can straight away find the area using Heron's formula. You can find the area using Heron's formula. You can check 48 square plus 14 square. 48 square plus 14 square. If that is 2,500 and 50 square is 2,500. If AB square plus BC square is equal to AC square, then the triangle is a right triangle. So in that case, you can find the area using half base into height. half into 14 into 48. Here it's not given that this angle is 90 degrees. It's not given, but you can check if it can be 90. You should find AB square plus BC square, 14 square plus 48 square, then 50 square. So if both are equal, this is 2500. If this is also 2500, then the triangle is a right angle triangle. In which case you can find the area using the formula half base into height, half BC into AB. If you don't want to check if it's a right triangle, you can just simply use Heron's formula and find its area. The sum of the area of the three sectors is what you see here. Pi is 3.14. So when you use 3.14, 39.252 centimeters, not 252, sorry, this is page 2. Ignore this. 39.25 centimeters square. The area of the three sectors is 39.25 centimeters square. So the area of the shaded region is area of the triangle minus the area of the three sectors. Make a note of these final answers. You can try it later. Please take down the figure. Take down this figure, write this information, and make a note of all these values. Work it later.
Ma'am, noted.
Good, good, yeah. Is it over? Should I wait?
Little wait.
Over, ma'am.
Okay, I'll just wait for 2 more minutes. So what you need to understand is here we cannot find the areas of the area of the sectors individually because we do not know the individual sector angles. So you cannot find the area of the sectors individually. You can only find the sum of their areas. You can only find the sum of their areas. The area of the three sectors put together you can find. Total area you can find, but not the area separately because we don't know the sector angle. You should do this. So you should find the area of, write out the area of the first sector, second sector, third sector, add all the three to find the total area. You see that pi r square by 360 is common everywhere. Bring out that common factor. Then in the bracket you will have angle A plus angle B plus angle C. Now you know that the sum of these three angles, these are the three angles of a triangle and their sum is 180. So 180. A plus B plus C is 180. Now 180 ones are 180 twos are. So pi r square by 2. And you know the value of r. Substitute and find.
Ma'am, finished.
Yeah, okay. Take down this figure, children. Draw this figure. Write down the question, draw the figure. So 5 minutes for that. We'll finish till here. The total area of the four sectors finish till here. You can understand this.
I'm completed writing question.
Yeah. Have we found the area of the 4 sectors? Please complete till here, whatever is visible on the screen. Find the total area of 4 sectors. All right, so what you see here is a trapezium ABCD. What you see here is a trapezium ABCD. Trapezium ABCD. You can see angle B is 90 degrees, angle C is 90 degrees, angle A is 60 degrees is given, angle D is 120 degrees given. Now, what are these? 4 sectors are formed with centers A, B, C, and D. So these sectors are formed with centers A, B, C, and D. The radius of each sector is 17.5 meters. The radius of each sector is 17.5 meters. We need to find the total area of the 4 sectors. The total area of the 4 sectors. Here, though we know the sector angle everywhere, 90, 90, 120, 60, we don't have to find the area of the sectors individually because we are asked to find only the total area. So this way we save time. When we find the total area directly, we save time. We don't have to find the area. You can find, see, if you want, you can find the areas individually and then add and get this total area. But you don't have to do it because you're not asked to find the areas individually. You have to find the total area of the 4 sectors. The total area of the 4 sectors. So the total area of the 4 sectors is equal to the area of the sector is angle A by 360 into pi r square. Angle A by 360 into pi r square. So similarly, angle B by 360 into pi r square, angle C by 360 into pi r square, and angle D by 360 into pi r square. The sum of all these, the sum of the areas of all these sectors will be the total area of the 4 sectors. So again, pi r square by 360 is common because the radius is the same for every sector. The radius of each sector is 17.5 meters. So pi r square by 360 common. So we have angle A plus B plus C plus D in bracket. And this total is 360 because the sum of the angles of a quadrilateral is 360 degrees. 360 cancels out in the numerator and denominator. So pi r square. So the sum of the areas of these 4 sectors is equal to pi r square. It's nothing but the area of one circle because the total angle is 360 degrees, right? Because it's a quadrilateral and we know that the sum of all the angles is 360 degrees, complete angle. So pi r square. For the triangle, in the case of a triangle, we got half pi r square because the sum of the 3 angles is 180 as against the total angle 360. So there we got half pi r square. This is pi r square. So 22 by 7 into was the value of the radius given and find the area of the 4 sectors. Next is to find the area of the trapezium. Now the formula to find the area of a trapezium is half sum of the parallel sides into distance between the parallel sides. See here, area of trapezium is equal to half sum of the parallel sides, AB plus CD. Children, am I audible?
Yes,
Yes,
ma'am.
ma'am.
All right. We finished the first part, children. We found the area. We found the total area of the 4 sectors. Please do it like this. This saves your time. You don't have to find the areas of the sectors individually. Don't do that. Find it directly like this. Okay. Now to find the area of the trapezium, the formula is half sum of the parallel sides. So parallel sides are AB and CD. Half AB plus CD into this. Now, how do we know that they are parallel sides? One is because they are marked, and you can also see this 90 degrees here. Even if this were not marked, 90, 90. What do you say? Co-interior angles are supplementary, so the lines must be parallel. Even if it is not given, even if this was not marked parallel here, you know that this is given to be 90, this is given to be 90. 90 plus 90, 180. Co-interior angles are supplementary, so the lines are parallel. So AB is parallel to CD. All right. So sum of the parallel sides AB plus CD into distance between them. Distance is CB or BC is the distance between them. That's what we have shown here also. DL. So here we draw DL perpendicular to AB so that we can make use of this triangle. We can make use of this triangle to find the length of DL. See, DL is equal to BC. BC is the distance between the parallel sides. We do not know the length of BC. So we are trying to find the length of DL, which is the same as the length of BC. We're trying to find the length of DL, which is the same as the length of BC. So from D, we draw a perpendicular DL. From D, draw DL perpendicular to AB. Why we draw this? So that we have a triangle, so that we have a right triangle, and so that we can use trigonometry and find the length of DL. We know that AB, we are given AB and CD is given. See, AB is 75 is given. CD is 50 is given. We know so we know the lengths of the parallel sides. We know the length of the parallel sides. We don't know the distance between them. So we draw this line segment which represents the distance between the two parallel sides. DL. And now let's see how to use trigonometry. Now in triangle DLA, DLA is a right triangle. In this right triangle DLA, we know that this angle is 60 degrees. We know that this angle is 60 degrees. We also know that AB is 75 meters, and if CD is 50 meters, LB is also 50. From here to here is 75 and LB is 50. So that means AL is 25 meters. AL is 25 meters. I'll come again. AB is 75 given. CD is 50. That means BL is also 50. So 75 minus 50. AL is 25. Why are we finding AL? Because AL is a side of this triangle. No, we are trying to gather as much information as possible of this triangle ALD. So in this triangle, we know one angle is 60 degrees. And we also found AL 25 meters. This is more than sufficient. In a right triangle, when you know any two things, when you know it could be two sides or one angle and one side. In a right triangle, when you know two things like this, you can use trigonometry and find the length of the unknown. So here we are interested in finding DL. Here we are interested in finding DL. We need to connect DL with the known things, 60 degrees and 25 meters. How do we use trigonometry? We need a right triangle. Okay, we have a right triangle. In the right triangle, we have to find the length of the line segment DL. We need to find DL. Okay, we have to find DL. Fine. This is a right triangle because by construction DL is perpendicular to AB. So it's a right triangle. All right, so we have a right triangle, and in the right triangle, we know angle A is 60 degrees. Fine. That's not sufficient. We need one more thing. So we can find AL. 75 minus 50, 25. AL is 25 meters. Now in this right triangle, we know one angle 60 degrees and the length of one side AL, which is, see, you cannot use anything. AL is a side of this triangle. AL is a side of this right triangle. So we know this angle is 60 degrees and AL is 25 meters. Now what is that which we have to find DL? We have to find DL. So what we have to do is, we have to use an appropriate trigonometric ratio and connect this angle 60 degrees with the sides DL and AL. The three things in the picture are 60 degrees, AL and DL, which we have to find. 60 degrees is the angle. AL, we know AL is 25 meters. DL, we want to find DL. So we are connecting all these three things, the two known things, 60 degrees and 25 meters. These two known things with the we are connecting the two known things, 60 degrees and 25 meters. These two things which we know with the unknown DL. Now, how do we connect this angle? This angle 60 degrees with DL and AL. So let's understand the relation, how the sides are related to this angle. How the sides are related to this angle. Now, for this right triangle, AD is the hypotenuse. This right triangle, AD is the hypotenuse. AD is the hypotenuse. Okay. Now we have the other two sides, DL and AL. Now for this angle 60 degrees, DL is the opposite side and AL is the adjacent side. I don't have to explain why. A triangle has three sides. Of the three sides, one side becomes the hypotenuse. But we have two other sides. Of the two other sides, this is the opposite side. See here, for 60 degrees, DL is the opposite side. There's no doubt there. So if this is the opposite side and this is the hypotenuse, this is the adjacent side. AL is the adjacent side. Right triangle, 60 degrees, 25 meters. We need to find DL. We are connecting this angle 60 degrees with DL and AL, with the sides DL and AL. For 60 degrees, DL is the opposite. See, this is the hypotenuse. Of the three sides, one is the hypotenuse. Now we have two remaining sides. One is the opposite side, the other is the adjacent side. So AL is the adjacent side, the side adjacent to 60 degrees. DL is the side opposite to 60 degrees and AD is the hypotenuse. Now we need to connect this angle with its opposite and adjacent side. We need to connect this angle with its opposite and adjacent side. So if you have to connect an angle with its opposite and adjacent side, the ratio available is opposite and adjacent. Tan or cot, tangent of an angle or cotangent of an angle. Tan 60 degrees or cot 60 degrees. Tan of some angle, tan 60 degrees or cot 60 degrees. Tan of an angle, tan of an acute angle in a right triangle connects the opposite side and the adjacent side. Cot connects the adjacent side and the opposite side. You can use any one of the two. You can either use tan or cot. You can use tan or cot. I had sent the links and I had requested you to watch the videos before today's class. Only if you had watched the videos, will what I'm saying make sense to you? So for 60 degrees, DL is the opposite side and AL is the adjacent side. We need to connect this angle 60 degrees with its opposite and adjacent side. Why opposite and adjacent? Because opposite is what we have to find. See, we only know this angle 60 degrees. Right angle you cannot take. Ignore the right angle. We only need a right triangle, but we cannot use any trigonometric ratio with this angle 90 degrees. We are going to use the we can use the trigonometric ratio with respect to any acute angle. So in that sense, we have only this acute angle 60. Of course, you can find this is 30. You can find this angle is 30. Well, we have 60 degrees here. Okay, so acute angle 60 degrees we have. For 60, this is the opposite side, this is the adjacent side. So tan 60 degrees is equal to opposite by adjacent. Tan 60, or you can say cot 60 is adjacent by opposite. Here, I've shown that triangle alone. Tan 60 degrees is equal to opposite DL by adjacent AL, which is 25. The value of tan 60 degrees is √3 from the table. The second link, tan 60 is √3. The first link which I shared today explains the relationship between the angle and the two sides. how the trigonometric ratios can be used. The second link gives you the table where you can find some specific ratios, trigonometric ratios of some specific angles. So tan 60 is opposite by adjacent, tan 60 is root 3, opposite DL by adjacent 25, cross multiply and find DL. So the length of DL is 25 root 3 meters. Now the area of the trapezium is half sum of parallel sides into distance between them, 25 root 3. Work that and find the area. And once you know the area of the trapezium, what should you find? The remaining area. You need to find the remaining area, right? Area of the remaining portion of the field. The area of the remaining portion of the field will be the area of the remaining portion of the field will be area of the trapezium. Area of the trapezium minus the area of the 4 sectors. Minus the area of the 4 sectors. Looks like I've not worked that answer. I've forgotten to work. Okay. So you can complete it. Area of the trapezium minus the area of the 4 sectors. Minus the area of the 4 sectors will give us the area of the remaining portion of the trapezium. Remaining portion meaning portion apart from the 4 sectors. I'll give you 15 minutes time, children. It's a very important question. It may look simple. You may have trouble working, so please work it now in the class. I've taken the question, so let me hide the question. I think I asked you to finish till the area of the 4 sectors. Yes, complete this, children. So this will not need 15 minutes. Maybe some 5 to 7 minutes.
Finished.
Yeah, thank you for acknowledging.
Finished, ma'am.
All right. Just see every part of the question and answer again, children. Any doubts? Ask me.
Ma'am, in the question itself, it's given that angle B and angle C are 90 degrees.
Yeah, it's given. It's given.
Okay.
It's given that angle B and C 90. It's given. All the angles are given. 60, 120, 90, 90, all given. So in this right triangle, how do we apply trigonometry? We choose this acute angle 60 degrees. We choose this acute angle 60 degrees. We need to connect this angle with two sides. Of which one should be that side which you want to find, the length of which you want to find. So DL. And another one whose length you know. So 60 is to be connected with DL and AL. For 60 degrees, this is the opposite side. And this is the adjacent side. Opposite and adjacent are connected using tan and cot. Tan of an angle or cot of an angle connects these two sides. So when you say tan 60 degrees, tan of an acute angle, tan of 60 degrees is equal to opposite side by adjacent. If you say cot 60 degrees, it will be adjacent by opposite. You can work both. Cot 60 degrees will be adjacent AL by opposite DL. When you say tan 60 degrees, it is opposite by adjacent. Opposite DL by adjacent AL, which is 25. Tan 60 from the table is √3. If you take cot 60 here, it will be adjacent 25 by opposite DL. And the value of cot 60 is 1 by √3. The value of cot 60 is 1 by √3. You will get the same answer. Cot 60 degrees is equal to adjacent by opposite. And the value of cot 60 is 1 by √3. So working this, you find the length of DL. So that's how trigonometry is useful. See, in this triangle, you know the length of only one side, only AL. Now using trigonometry, you were able to find the length of DL, the length of the line segment DL. We do not know AD also. We only know the length of this side AL. Using this, we found DL. So trigonometry helps us to find the lengths of an unknown angle. The length of an unknown side in a right triangle. In a right triangle with minimum information. In a right triangle, when you just know the length of, oh, I'm so sorry. In a right triangle, when you know the measure of an acute angle and any one side, you can find the length of the remaining two sides, which is otherwise not possible. I want you all to work this by yourself. I'm not showing the complete answer, children. I want you to do it. All that which is marked here is given. Only this is the construction. What you see in dotted lines is a construction. Construction, draw BL perpendicular to DC. This we do. This is a part of the answer. Draw BL perpendicular to BC is a part of the answer. This figure is given with AB 7 units, DE 4 units, 60 degrees. All this is given to you. Yes, children. Find the area of the shaded region. Do it yourself. That trigonometry part alone, you can see it here. Understand this by yourself. I'll ask somebody to explain.
How to find value of CD?
To find the value of CD. It's given, no, here BC's, it's BC 7, right? If BC 7, CE is also 7 because this is a sector. It's given it's a sector. BFEC is a sector. BFEC is a sector. So that means CB is the radius. CE is also the radius. So radius here is 7. So this is also 7. So 7 plus 4, 11. Very good. That was a good question, Srinivasan. Which means you've been paying attention to every detail given. Very good. So it's given there's a sector. CBFE is a sector whose angle is 60 degrees, which means CB is the radius, CE is the radius. CB radius, CE radius, because this is sector. CBFE is a sector. So the CB is marked 7 units, 7 centimeter. CE is also 7 centimeters. So CE plus ED is CD, which is 7 plus 4, 11.
Okay.
Very good, Srinivasan. Is it over, children?
No, ma'am.
Okay.
No, ma'am.
All right. Yeah, please. All right. So this figure ABCD is what? What is ABCD, children? Is it a trapezium? is?
Yes, ma'am.
It's given as a trapezium. You can see the parallel sides marked here. AB is parallel to CD. In a quadrilateral, if one pair of opposite sides is parallel, then it's a trapezium. In a quadrilateral, if one pair of opposite sides is parallel, then the quadrilateral is a trapezium. ABCD is a trapezium. This one, this BC, BFEC, this one, BFEC is a sector. Sector angle 60 degrees, which means CB radius, CE radius. So if CB is 7, CE is also 7. It's given AB is equal to BC. That's a different information. That's not because they're the radius. AB is equal to BC. Both are equal to 7 centimeters. Okay. D is 4. So we are not given. CE is not given. But since we know CB is 7, CE is also 7 because radius. So given all this, we need to find the area of the shaded region. So clearly the area of the shaded region is area of the trapezium ABCD minus the area of the sector. Minus the area of the sector. Area of the trapezium ABCD minus the area of the sector will give us the area of the shaded region. So now to find the area of the sector, what do you need? You need the sector angle. Yeah, we know it is 60 degrees. Okay. Then we need the radius. That also we know, 7. So easy. So to find the area of the sector, we have all the info. 60 by 360 into pi r square. We know the sector angle is 60 degrees. We know that the radius is 7 centimeters. So nothing difficult about finding the area of the sector. Now about the area of the trapezium. Sum of the parallel sides. Half sum of the parallel sides into distance between them. Parallel sides are 7 and 11. 7 plus 4, 11. 7 and 11. Okay, parallel sides we know. Distance between the parallel sides is not known. Distance between the parallel sides is not known. So we construct BL perpendicular to CD. So this acts as the distance between the two parallel sides. BL is the distance between the two parallel sides. The perpendicular distance between the two parallel sides. And we take up the right triangle BLC, where you know this acute angle 60 degrees. So we take up this right triangle BLC, where we know this angle is 60 degrees. And we know the side BC is 7 centimeters. We know the side BC is 7 and we know one acute angle. So with the help of 60 degrees and 7 centimeters, we want to find BL. We want to find the length of this line segment BL with the help of this acute angle 60 degrees and the length of this line segment BC, which is 7 centimeters. For this angle, in this right triangle BLC, for this acute angle 60 degrees, BL is the opposite side and BC is the hypotenuse, not only for 60 degrees. In this right triangle, BC is the hypotenuse. In this right triangle, BC is the hypotenuse. So BC is the hypotenuse. We know it is 7 centimeters. 60 degrees. We know one acute angle 60 degrees. And we need to find BL. For 60 degrees, BL is the opposite side. So we need to connect this 60 degrees, this acute angle 60 degrees with this side BL, which we have to find, and the known side BC. So for 60 degrees, BL is the opposite side. BC is the hypotenuse in the right triangle. How do you connect this angle with its opposite side and hypotenuse? Opposite hypotenuse. Sine. Sine of 60 degrees. You can use sine or cosecant. You can use sine or cosecant. These two ratios connect the opposite side and hypotenuse. Opposite and hypotenuse. So sine 60 degrees in this right triangle, sine 60 degrees is equal to opposite BL by hypotenuse BC. The value of sine 60 degrees from the table is √3 by 2 is equal to BL is not known. So BL by BC 7. On working this, we find BL is 7 √3 by 2. So using this, we find the area of the trapezium. We know how to find the area of the sector. The difference is the area of the shaded region. So the important thing here is to identify CE as the radius. Important thing here is to identify CE as the radius. CB 7, so CE is also 7. That's one thing. And to find the distance between the parallel sides, we use trigonometry. Trigonometry. 60 degrees, BL is the opposite side. For 60 degrees, BL is the opposite side. So we connect opposite and hypotenuse using sine 60 degrees. Just wait for 2 more minutes in case you have not finished. All right. These are semicircles, children. Please, it's a freehand drawing, so just managed to do this much. These are semicircles. This is a semicircle, 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 semicircle. These are semicircles, children. Identical ones. It's a design. All the semicircles have the same diameter or the same radius. The semicircles, the 4 semicircles, they have the same diameter. Yes, one of you will explain this. I said this earlier, but I did not ask anybody. This one of you is definitely going to explain this. Go through the working. You cannot see the what do you call the shaded region? Let me just check. Okay. So this one, you need to find, see your children, this is a square. You see this design in the middle. You see this design in the middle. That's not shaded. That is not shaded. Outside this design, the area outside the design is shaded. The area outside this design, see, I'm calling this as the design. I'm calling this as the design. This design is not shaded. Outside the design is shaded. Outside the design is shaded. So this is unshaded. This is unshaded. This is shaded. All this shaded. Yes. Who can tell me? How do we compute the radius? How do we find the radius of the semicircles?
Ma'am, by using the side of the smaller square.
By using the side of the smaller square.
3 by 2.
The side of the smaller square is given, is it? This one?
No, ma'am, that's
Okay, let me ask you questions like this. How much is this given, children? How much is this given to be?
3.
And what is this for the semicircle? This line segment? What does this line segment mean for the semicircle? Radius, diameter. Radius or diameter? Radius. Radius. Now coming down, what is this? What is this line segment? See, this is not attached to the semicircle, but this value is equal to what? Radius or diameter of the semicircle, this portion. This one is equal to this, right? No, see here, this one is equal to this. What is this for the semicircle? Diameter or radius? What is this for the semicircle? Diameter. This is the diameter of the semicircle. This is the diameter. So we have a similar line segment here. This is the diameter. This is not the diameter of the semicircle, but the length of this line segment will be equal to the diameter. This is not the diameter, but the length of this one is the same as the length of this one. This is the diameter of the semicircle. So this also, the value of this one will also be equal to D. It's not the diameter, but its value is equal to D. Now coming down, how much is this? What is this for the semicircle? Radius or diameter?
Radius, ma'am.
Radius. This is the radius. For the semicircle, this is the radius. And this is 3. This is 3. So we know that this total length is 14. We know that the total length here is 14. The side of the square is 14. The side of the square is 14. The side of the square is 14. So this line segment will also be 14. The length of this line segment is also 14. The length of this line segment is also 14. So 14 is equal to 3 plus radius plus twice radius because diameter, so twice radius. 3 plus radius plus twice radius because it's diameter plus radius plus 3 is equal to 14. Is equal to 14. 3 plus this is the radius plus diameter plus radius plus 3 is equal to 14. Working this, you can find the value of R. What is R? This one, radius of the semicircle. But now when you join, when you connect all the diameters, you get a square in the middle. You get a square in the middle. What will be the side of the square? Because the radius is 2 centimeters, the diameter is 4. So the side of the square is 4 centimeters. Because see, this is the diameter. For the semicircle, this is the diameter. Diameter. Radius is 2 centimeters. So the diameter will be 4. The diameter is 4. This is 4, this is 4, this is 4, this is 4. So the different things we have in this figure are one big square, side 14 centimeters. Semicircles, radius 2 centimeter. And there is a square formed in the middle whose side is 4 centimeter. Now we know all the values. For all the different plane figures we see here, the square in the middle, side is 4. For the semicircle, radius is 2. And for the outer square, the side is 14. And now we have to find the area of the shaded region. I told you this region, area of this region. So that will be the area of the square, the outer square minus the area of this design in the middle, minus the area of the design in the middle. So see here, area of the square, 14 into 14, 196 centimeters square. Unshaded region, this one is made up of 4 semicircles and 1 square. 4 semicircles and 1 square. See, 1 square and 4 semicircles. So 4 semicircles meaning 2 circles. So you can see the area of 1 small square and 2 circles here. 2 pi r square. Pi r square into 2. Pi r square into 2. So area of the shaded region will be area of the shaded region is equal to area of the square 196 minus unshaded 41.12, which is this one 154.88. Please complete this answer. Those who have finished can think about the next one. This entire thing is shaded. Find the area of the shaded region. This entire thing, whatever you see here is shaded. The figure is entirely shaded. We need to find the area of the shaded region. Children, please finish this one. Finish this one and then take down this figure. All right. Who can tell me the answer for the 9th one?
Area of square plus
Area of the square plus area of the two major sector, ma'am.
Area of the two major sectors. Very good. Area of the square plus the area of the two major sectors. What's the major sector angle?
270 degrees.
270 degrees. I've given side of the square 28 meters. Side of the square 28 meters. Sorry, 28 centimeters. Side of the square. Radius of each circle is half the length of the side of the square. Radius of each circle is half the length. So 28 by 2, 14 centimeters. Find the area of the shaded region. So it's the area of the square 28 into 28 plus the area of the two major sectors 270 by 360 into pi r square 14 square because radius is half of 28 14 square. Please complete the 9th answer. All right, write down this question now. The next one will take a little longer time, so I think we'll take it up in the next class. We'll take up the 10th one in the next class. Do this in the next class. Take a simple question now. Find the area of a quadrant. Write down this question, children. Find the area of a quadrant whose perimeter is 25 centimeters. Find the area of a quadrant whose perimeter is 25 centimeters. This is the question. Find the area of a quadrant whose perimeter is 25 centimeters.
Ma'am,
Yes.
is it 198.6 centimeters?
Is it? Are you giving me the answer for the area of the circle?
Area of the quadrant.
Area of the. Oh, area of the quadrant. 1 minute. No, what was my question? What was my question? Please read my question.
Find the area of a quadrant whose perimeter is 25 centimeters.
Yeah. Find the area of the quadrant whose perimeter is 25 centimeters. So area of the quadrant is what you're saying, right?
Yes, ma'am. I'll check.
What is the radius?
Ma'am, 15.9.
No, I have a different answer. Please check your working again.
Ma'am, I'll share the working.
Yeah, let me see. Yeah. Children, my question is find the area of a quadrant whose perimeter is 25 centimeters. Perimeter of the quadrant is 25 centimeters. You should find its area.
Ma'am,
No, Arnav, you have to think again.
ma'am, can you hear me?
Yes, yes, please tell me. Who's this?
Priyashni, ma'am.
Yeah, tell me.
11.95.
No. Area of the quadrant, is it?
Yes, ma'am.
No, 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 no.
Ma'am,
Yes.
ma'am, is it 38.5?
Who's this?
Ma'am, Ravya.
Ravya. What's the value of radius, Ravya?
Ma'am, 7 centimeter.
Yeah, please read out. How did you get 7? Yes, Ravya. Is it possible?
Ma'am, my internet is slow, ma'am. Could you hear me?
Is it possible for you to take a picture of your working and share on WhatsApp now?
Yes, ma'am. Yes, ma'am.
Yeah, yeah, do that right away. Yes. Her answer is right. Radius is 7 centimeters. She's right. Ravya is right. 7 centimeters. Try, children. It's very
Ma'am, I
simple
found
one.
out my mistake. I took the length only of the arc and not of the 2 radii.
Correct, correct. Yes, Ravya, quickly. Okay, I haven't got it. Oh, yeah, I just got this. Very good, Ravya. Very good. So, perimeter of a quadrant. Perimeter of the quadrant is given to be 25 centimeters. So when you walk along the boundary of a quadrant, when you walk along See it in your mind. See a quadrant in your mind. When you walk along the boundary of a quadrant, you're walking on its radius, again on its radius, and then on the arc. R plus pi r by 2. I'll share the picture of this answer. A quadrant is a region bounded by 2 radii and an arc. A quadrant is a sector. How do you find the perimeter of a sector or a perimeter of a quadrant? Radius plus the length of that arc. What is the length of that arc? It's 2 pi r for the circle. It's 2 pi r for the circle. It's 2 pi r by 2 for a semicircle. It's 2 pi r by 4 for a quadrant. So the length of the arc in a quadrant, the length of the arc in a quadrant is 1/4 of 2 pi r. 2 pi r is the perimeter of the circle. 1/4 of 2 pi r. That is 2 pi r by 4, which is pi r by 2. Pi r by 2 is the length of the arc in a quadrant. So pi r by 2 plus r will be the perimeter of the quadrant, which is equal to 25. On working this, you get radius is 7 centimeters, and then the radius, and then the area of the quadrant is 1/4 of pi r square, which is 38.5 centimeters square. So see, very easy one, but it can trick you. Very easy. The question was very simple. It was so easy to understand. Very easy to understand. But it's tricky. Because we don't realize that perimeter is the sum of the radius. The sum of the radius, radii, and pi r by 2 and the arc. So be careful there. Perimeter is the length of the boundary of a closed figure. How can you take only the length of the arc? What is perimeter? It's the length of the boundary of a closed figure. So what makes a quadrant? Radius, and then that arc. R plus pi r by 2 is equal to the perimeter, which is 25. All right, children. So that's it for today's session. I believe all of you have completed your work during the session itself. I gave you sufficient time to work, and you had the freedom to stop me if you hadn't completed. I assume that you worked all in the session today. Thank you. Thank you for that acknowledgement. Thank you.
Yes, ma'am.
Very good, children. Very good.
Thank you, ma'am.
All right. That's it for today's session. Thank you so much. Good night. If you have any questions, please state that.
Thank you, ma'am.
Thank you, ma'am.
Thank you, children. Good night. Thank you, children. Good night.